My name is Karthik Taluri and today I'm going to talk about normal distribution. Some authors attribute the credit for the discovery of normal distribution to de Moivre, who in 1738 published in the second edition of his book, The Doctrine of Chances, the study of the coefficients in binomial distribution. In 1823, Carl Friedrich Gauss published the monograph in which, among the other things, he introduces several important statistical concepts, such as the method of least squares, the method of maximum likelihood, and of course, the normal distribution. Although Gauss was the first to suggest the normal distribution law, Laplace made significant contributions. It was Laplace who first calculated the value of Gaussian integral in 1782, proving the normalization constant for the normal distribution. Now let's discuss some of its basic concepts and meaning. In statistics, a normal distribution or Gaussian distribution is a type of continuous probability distribution for a real-valued random variable. The general form of its probability density function is given in the equation. The parameter mu here is the mean or expectation of the distribution and also its median and mode, while the parameter sigma is the standard deviation. The variance of the distribution is sigma square. The standard deviation is a measure of the amount of variation or dispersion of a set of values. A low standard deviation indicates that values tend to be close to the mean, also the expected value of the set, while a high standard deviation indicates that the values are spread out over a wide range. Here, for the graph with the blue line, the mean is 0 and variance is 0.2, hence the graph is much narrower and closer to the mean. The graph with the red line represents the standard normal distribution where mean is 0 and variance is 1. The graph with orange line has high variance, therefore graph is wider and the values are away from the mean. Mean could also be negative as represented by the green graph. A single standard deviation covers 34.1% of the values on the Gaussian curve, while it's 13.6% from the first to second standard deviation and 2.1% for the second to third standard deviation on one half of the Gaussian curve. Now let's look at a small example on how central limit theorem works. Let's take an example of rolling a die. Dice are ideal for illustrating the central limit theorem. If you roll a 6-sided die, the probability of rolling a 1 is 1 by 6, a 2 is 1 by 6, and so on. In a classroom situation, we can carry out this experiment using an actual die. Consider a classroom of several thousand people in a class and each of them are given a die. First, the students are given a single die. The outcomes are recorded and as you can see, the frequency of each of the outcome is almost equal. Now the students are given 2 dice to roll. The outcome of each of the die is averaged with the other die and frequencies are recorded. Now the graph tends not to be flat. As we increase the number of dice, the graph almost tends to standard normal distribution. This outcome is synchronous with the central limit theorem, which states that the distribution of sample means approximates a normal distribution as the sample size gets larger, regardless of the population's distribution. And eventually, the graph reaches a normal distribution. Now let's look at a few applications of normal distribution. In biology, the logarithm of various variables tend to have a normal distribution after separation of male and female subpopulations, with examples including measures of size of living tissue, length, height, and skin area. Here in the graph, approximately 34% of the people are less than 1 standard deviation from the average height, 1.64 meters, and 17% of people have height between 1.68 and 1.72. Normal distribution is also used in standardized testing. Results can be made to have a normal distribution by either selecting the number and difficulty of the questions as in the IQ test or transforming the raw test scores into output scores by fitting them into normal distribution. For example, the SAT's traditional range of 200 to 800 is based on a normal distribution, with a mean of 500 and a standard deviation of 100. Certain quantities in physics are distributed normally. Let's look at the example of quantum harmonic oscillator. It is the quantum mechanical analog of classic harmonic oscillator. As we can see here, probability density function of ground state in a quantum harmonic oscillator is a normal distribution.